Okay, we're going to get started looking at the different types of graphs that you could see when we're going ahead and working here. So the first one we're going to look at is a box plot, box and whisker. So this one is a nice one because it is all labeled with all the different pieces, the quartiles and the maxes and the mins. Big thing to do when you draw a box plot, if they ask you to, is make sure you provide a number line scale to show what those magnitudes of the numbers are and label it what you're talking about. The next one that we're going to go ahead and talk about is we are going to talk about a stem plot. Stem plot, stem and leaf. The number to the left is your stem. The numbers to the right, the one-digit numbers are your leaves, so they're always one-digit numbers as leaves. So what we have here is we have the first number 3/4 is the number 34, and the number down here 15/0 is 150. So make sure you know how to read that, and the most important thing is to provide a key and a label on what you're talking about for a stem plot. Next thing we have is a back-to-back stem plot. And when I look at a back-to-back stem plot is two sets of distributions on the same stem. So these are my stem right down the middle, the 4, 5, 6, 7, 8, 9. My leaves are to the right for Wednesday. My leaves are to the left for Monday. And if you notice, the big thing is Monday's backwards, if you look. So this is 4, 9. That's 49, not 94. 51, 56. Make sure that you have labels on this as well. This one doesn't have a key, so that's not a good thing. You would lose points without a key, so make sure you show a key. The one over here is a split stem plot. A split stem plot is when you have too many of one set of numbers. So for example, here in the 9-8 range, that this is 980 to 989. There's a lot of data, and if we had just done one stem on that, it would have been a really, really long line of numbers. So what we want to do when we work on that is we want to make sure that we split it out into two different parts. And what that would do is that this part is 980 to 984, the first one, and then the second one is 985 to 989. Again, no key here, so that would be a bad thing, so make sure you have a key. Next one, histogram. Histogram is these two are very similar. That's why they're on the same chart, the histogram and the dot plot. Histogram is not a bar graph. A bar graph would be separate bars. Histogram is all together bars, so no spaces between the bars, as you noticed. The scale on the x-axis is constant in terms of it goes up by 5. The scale on the y-axis is constant. It goes up by 25. Make sure you do that. Make sure you label everything. Make sure you give a name to your graph. Dot plot is pretty much the same thing, but instead of bars, we use dots. This frequency is going to pretty much be your left, but it's oftentimes not labeled. And then along the x-axis is where we have an equally spaced set of numbers, so we go up by 4 on those heights. Don't forget labels. Don't forget to keep those dots equally spaced out. So we'll do a quick example of comparing two sets of distributions. You could be asked to describe. Describe is what you do with one. Compare is what you do with more than one. So what you're going to do when you work on this one is you are going to use the acronym CUSC, C-U-S-S-C. The first C stands for center, so there are two choices for center. First one is median, second one is mean. Typically what it is we use mean on symmetric distributions, so things you can fold in half. We use median on everything else. However, if they are going to give you a graph of some sort, I would tend to lean towards median because median is much easier to identify. So in the case here, the median of distribution A, as you see right in the middle, is about 136. The median of B is right in the middle, is 138. Now be careful. Just saying the median of A is 136 and median of B is 138 will earn you no points. What you need to do is you need to put compare phrases in there. You need to use phrases like is greater than, is less than, or is the same as. So in this case, we would want to say the median catapult distance of distribution A is less than the median catapult distance of distribution B. And notice, I compared and I did context. Very, very important that you do that. The next U stands for unusual points. So what you're going to look for is any holes in the distribution. What I mean by holes is any place where you see no data. You're also going to talk about any modalities. So if there's more than one high point, you want to kind of talk about that. And then you want to also talk about outliers. And in the outliers, if you look on this slide right here, I kind of give you the description of how to find an outlier. Please let me know if you have any questions. We can go over that separately. In this question, it doesn't appear we have any obvious outliers from a glance, so there appears to be no obvious outliers in either distribution. The next one is S, CUSS. So CUS, the S stands for spread. Because we use median for center, we want to use either IQR or range for spread. If it was going to be mean as our center, we would have used standard deviation as spread. So in this case, we want to go ahead and get the range. So in this case, the range is pretty easy to get. It's max minus min. In this case, if you go back, I'll go back up a couple slides so we can look at the picture again. We see that the range of A is definitely a lot larger than the range of B. That's what you want to say. You want to say the range of distribution A is greater than the range of distribution B. The last S stands for shape, and when we want to talk about shape of a distribution, shape is going to be one of three things usually: roughly symmetric, skewed left, or skewed right. I mentioned roughly symmetric is kind of like what you learned about in grade school. You can fold it in half, kind of mirror image thing. Skewed left, remember, look at your left foot. The tail goes to the left. The big bump is on the right-hand side. Skewed left, left foot. Skewed right, right foot. Another one you could see is uniform. It looks like a rectangle. Biggest thing I can say here is please never use the phrase normal. Don't describe the distribution as normal because there's a lot more stuff we have to prove to call something normal. So in this case, both distributions of catapult distances are roughly symmetric and mound shaped, and that would be our comparison. We would hit all those points.